Hello everyone. So friends, in our previous lecture we discussed about what is dynamic programming. So in this lecture we will discuss more about dynamic programming and its relationship with recursion. We will see how recursion and dynamic programming go hand in hand. So here if you see, we mostly use dynamic programming to provide an optimization over recursion. So here let's say we use recursion to solve any problem. So usually it happens that when we solve a recursive problem, we tend to make the code inefficient. Which means using recursion we can solve the problem, but what it happens is the problem is solved but it tends to take more time. So in our previous lecture we discussed that how dynamic programming usually help us to solve a complex problem by breaking it down into smaller sub-problems and then solving those sub-problems. And while solving those sub-problems, what we do is we simply store the result of those sub-problems, and whenever that sub-problem comes again into picture, we usually extract the stored result and we reuse rather than computing it again and again. So similarly, when we solve any recursive problem, what we do is we simply break it down to smaller sub-problems and we solve those sub-problems and we store those results. So whenever that sub-problem comes back into picture, we usually use the stored result of that sub-problem and we avoid recalculating the solution to that sub-problem. So by doing that, a recursive problem gets optimized. So if we see, the basic definition of dynamic programming is basically taking recursion plus memorization. So here we tend to solve a problem recursively, and when we solve the sub-problem, we usually memorize those solutions. And later point of time, if that sub-problem comes again back into picture, we use the memorization solution rather than again calculating those sub-problems. So friends, in order to explain what is the problem with using recursion directly and what's the advantage of bringing in dynamic programming with recursive solutions, we'll see an example. So we'll take the example of Fibonacci series. So what is Fibonacci series? So as per the definition, it is a series of numbers in which first two numbers are 0 and 1. After that, each coming number is the sum of the two preceding numbers. So if we go by this definition, then this is the formula which comes out. So here first two numbers are 0 and 1. So here you can see the Fibonacci of 0 is 0 and Fibonacci of 1 is 1, which means that first two numbers are 0 and 1. After that, each coming number is sum of the two preceding numbers. So let's say I want to calculate the nth Fibonacci number. So in order to calculate the nth Fibonacci number, what I can do is I can simply do the sum of the n-1th Fibonacci number and n-2th Fibonacci number. So which means that we are simply doing the sum of the two preceding numbers and getting the current number. So here you can see this is the Fibonacci series of first few numbers, where the first two numbers are 0 and 1, which is this. So let's say we want to calculate what's the Fibonacci number 2. So the Fibonacci number 2 is the Fibonacci number 1 plus the Fibonacci number 0. So here you can see the Fibonacci number 1 is 1 and Fibonacci number 0 is 0. So we do 0 plus 1, we get the number 1. If you want to calculate Fibonacci number 3, we simply take the two preceding numbers, which is 1 and 1. So when we do 1 plus 1, we get 2. And similarly, 1 plus 2 will give 3. 2 plus 3 will give 5. 3 plus 5 will give 8. 5 plus 8 will give 13. And 8 plus 13 will give 21. So this is how the series goes. If you want to calculate any Fibonacci number, we simply take the preceding two numbers, we do the sum of it and we get the number. So this is the basic formula to calculate the Fibonacci number. So friends, in our next lecture, we'll take this example of Fibonacci series and we'll see that how plain recursion in calculating the Fibonacci number is less optimized, and then we'll see that how we can bring dynamic programming more optimized. I hope you like this video. Thanks, have a nice day.